Hi everybody, just a quick video to go over the drag and drop pedigrees that you had to do last week. Everybody, so I'm going to do a quick review here of the drag and drop pedigrees that you had to do last week for genetics. Okay, start with the first one here. A father cannot roll his tongue, but a mother can. Of their 4 children, one daughter cannot roll her tongue. And both sons can roll their tongue. So if you remember from the problem, it said earlier on top of this, and we can't see it now, but it does say that a tongue rolling is a dominant trait, so not being able to roll your tongue is recessive. So if we have the father here and the mother, father cannot roll his tongue, so we're shading him in. And the mother can. So the mother will leave like this for now because we don't know if she's homozygous recessive or homozygous dominant. They have 4 children. They have 2 daughters and 2 sons. Now the problem says here that one daughter cannot roll her tongue, so we can shade her in. And we can actually already even put the genotypes here. The other daughter and both sons can roll their tongue, so we leave them like this for now. Now, because this daughter here is homozygous recessive, we can immediately assume that the mother is then uppercase, lowercase. So she's a carrier for sure. Now, she can roll her tongue, and so we can assume that she's heterozygous because she has a daughter who cannot roll her tongue. Now, for the rest of them, we can all assume that they have at least one lowercase, seeing as the father is homozygous recessive, and then we can fill it in with an uppercase, seeing as they can roll their tongues. So this is for the first one. Okay, and in the next one, we have the eye colors of mother and father both have brown eyes, and their 2 sons have blue eyes, and their 2 daughters have brown eyes. One daughter carries the gene for blue eyes, the other does not. So we can fill that in. So we have a father and mother with brown eyes. Oops. We have 2 sons here and 2 daughters. Now the 2 sons have blue eyes. So immediately, and I'm going to use a lowercase b here. Now immediately, since the 2 sons have blue eyes, we can definitely fill in this. They must be heterozygous. If they have brown eyes, but they have 2 sons that have blue eyes, then they must have the recessive gene. Okay, and then one daughter carries the gene, so we know this for sure, and then the other does not. So we could definitely assume that we are like this. Okay, so this is the pedigree for the eye color. If we move on to the pedigree for diabetes, we have a father who carries the recessive gene for diabetes and a mother who does not. So father here, mother. The father carries it, the mother does not. Now we can assume here, based on the problem, that if she doesn't carry it, then she probably doesn't have it either. Okay, they have 2 children, a daughter and a son. So here we will put her daughter and the son here. Sorry, I will change that, and I will put the son here and the daughter here. Now the daughter doesn't suffer from diabetes, and marries a man who does not carry the gene for diabetes, let's just fill in this for now. They have one child, a girl who is a carrier in generation 3. So she's a carrier here. And the father doesn't carry, then definitely the mom must be a carrier here. And let's also fill this in here. Now let's look at the son, and we can fill out the genotypes in a little bit. So we have the son who marries a diabetic woman, and they have 2 boys, both whom suffer from diabetes. So if we fill this in, we could also fill in the genotypes here. So for the 2 sons to be diabetic, that means definitely the dad was carrying it here, so he must be heterozygous. So, and then going back to the daughter here, we can definitely fill in these, and these will make sense as we look at the what are now grandparents. Okay, so we will move on to the last one, which is the blood types. A father has blood type A, a mother has blood type AB. They have 3 children, a son with blood type A, another son, and a daughter. The daughter then marries a man with blood type O. So let's look at this. So we have a father here and the mother. The father is blood type A. Now, we don't know what his second allele is. Now the mother is AB, so we can definitely fill this in here like that. They have 3 children. They have a son. They actually have 2 sons and a daughter. Now they have a son who's blood type A, and again we'll leave the second allele for now. They have another son who's AB, and we could fill that in, and they have a daughter who is B. And again, let's just fill that in for now. Now, she marries a man who is blood type O. He is blood type O, so he's definitely lowercase I. And they have a daughter who's O. Now, here's where we can start filling in some stuff. If the daughter here, I'll use a different pen. If the daughter here is O, then that means the mom must be carrying that recessive. Now, if this daughter is carrying that, then definitely we can go back to the grandfather here, and we could fill this in like that. Okay, meanwhile, what I'll do is I'll fill in this here. She's AB. Actually, I don't even think that was necessary for me to do that. Let's just leave it at that. Then if we go back to the son, this son right here. Okay, now this son is fine. Now this son right here, he definitely got his A from his mother here. Okay, so he definitely got this A because he didn't get the B. Now from the father, he could have either gotten either one of those. Okay, so this son is actually one where it's still a mystery. He could be IAA, or he could either be IA and a lowercase I. So for that one, it's still kind of a mystery. We don't know. He can either be either one. Hope that was helpful. Go over your pedigrees using your Google Doc, make any corrections necessary, and use the Google Doc comment feature to put in your comments with the mistakes or errors that you made.